All right, so I did want to go over just briefly how to figure out the probability of getting a sum of 7, 11, or 12 with a fair die. So sum of 7. So getting a sum of 7 with a fair die, or 2 fair die, rather. I'm going to use 2 different colors. One color will represent one die, the other color will represent the other die. So recognize to get a sum of 7. So the analogy here is one of our die is red, the other die is black. So our red die could come up 2, and the black die could come up 5. And in fact, why skip ahead? Red die could come up 1, black die could come up 6, red die could come up 3, black die could come up 4. Our red die could come up 4, and our black die could come up 3. And I think you see the pattern. 5, 2, 6, 1. So, what is the probability of rolling a sum of 7 with 2 fair die? Well, there's 1, 2, 3, 4, 5, 6 ways to do it. Oh, slippery. 6 ways to roll a sum of 7. Out of how many possible outcomes? Well, remember when you roll 2 die, there's 36 total possible outcomes. The 36 coming from red, the first die could come up 1, the second die could come up 6 through 1, so you have 6 possible outcomes there. The red die could come up 2, the black die could come up 6 through 1, so there's another 6, there's another 6, there's another 6. So hence the 6 times 6 for the 36 possible outcomes. I want to look at the 12 one. Okay, so the probability of rolling a sum of 7 would be 6 out of 36. Let's ask the probability of getting a sum of 12. That's kind of a boring one. 8. Let's look at 8. It'll get us what we want. So the probability of rolling a sum of 8, well, let's get our 2 die out. 1, that wouldn't be enough. We'd have to roll a 7, so we'll have to start at 2. Red die could come up 2. Black die could come up 6. Red die could come up 3. Black die could come up 5. Red die could come up 4. Black die could come up 4. Red die could come up 5. Black die could come up 3. 5, 6. I don't know why this is giving me so many issues. Okay. So recognize, so from before, looking at our example of 7, 3 and 4 was a case, 4 and 3 was another case. So this 3 and 4, 4 and 3 were counted twice. However, consider down here, we only wrote 4 and 4 once, and this is why I do it in 2 different colors, because you already know where I'm going with this. Recognize 4 and 4 is only written once. We did not write another 4 and another 4, and that's to say, we wrote 3 and 5 twice, because red die could come up 3, black die could come up 5. Similarly, the red die could come up 5, and the black die could come up 3. Now, if we played that same game with the 4 and the 4, recognize we would have what we started with. The red die is 4, the black die is 4. Or, the red die could come up 4, and the black die could come up 4. So we would double count that. So, keep in mind that, you know, this 1 and 6, so if the numbers are not the same, they do end up getting written down twice. We count them twice. When you see it in 2 different colors, you can recognize instantly why that is. If the numbers are the same, we only write them down in our list once. So the probability of rolling a sum of 8, well, there's 1, 2, 3, 4, 5 ways to do it out of 36 possible outcomes. Okay, So do recognize in this example, the events are non-overlapping. That means you cannot roll a sum of 7 and a sum of 11 at the same time with 2 fair die. You can't roll a sum of 11 and a sum of 12 at the same time. So the events are non-overlapping. Non-overlapping because you can't accomplish any two of these 3 events at the same time. So recognize because they are non-overlapping, it's going to be a direct sum of the probabilities. And then recognize MyMathLab does want an integer or a simplified fraction. So do the addition, get a fraction out, and then reduce. All right, thanks for your attention. I'll see you on the next one.